When you're trying to evaluate an integral, like an indefinite integral here, the first thing you want to probably try to do is just see if you can intuitively figure it out. Like, okay, if I'm trying to integrate just sine of x, I know the derivative of cosine is negative sine, so the antiderivative of sine must be negative cosine, right? That's one we could do intuitively. This one isn't as intuitive because there's an x times a sine function. So you can try u substitution, but then what do you let u be? If you let u be sine of 6x, then you don't have du. This is a problem that requires integration by parts. And so integration by parts works by choosing a u. In this case, I'm going to choose u to be x, and then choose a dv. I'm going to let this be dv. And integration by parts says you can evaluate the indefinite integral by doing u times v, not dv, u times v minus the indefinite integral of v du. And I'm letting u be x because in the formula for integration by parts, du is still being integrated, right? So I chose u to be x. That way it disappears into just a constant, and now it's a much simpler function over here. Okay, so when you pick a u, you're trying to pick something usually so that the powers keep descending until there's nothing left. So we need dv. So look how the formula starts. This is what we're doing. This is our u. And now this must be our dv because you have to substitute the whole thing. So dv has to be sine of 6x. And now careful with v. V is the antiderivative of dv, right? Because if this is dv, that's the derivative of v. So if we need to figure out what v is for the rest of our formula, it needs to be the antiderivative of dv. So that's 1/6 sine of 6x. And if you're not sure where that came from, that's back when we used to do antiderivatives of just sine of 6x. Look, when you take this derivative, cosine. And it needs to be negative. I didn't even use an antiderivative of the trig function. Okay, that's the correct antiderivative because when you take a derivative of cosine, it's negative sine, so that's why I stuck a negative sign out here. But the derivative of the innermost function, the derivative of 6x, is 6. So when you take a derivative, you're multiplying a 6 up front. That's why you have to have the 1/6 over here to compensate. So you'll want to go back and review. You want to look up like a video for the antiderivative of sine of 6x if you're not sure where I get this part from. Okay, so that's everything. Let's plug it into the formula where it's supposed to go. It's u times v minus the integral of v, which is negative 1/6 cosine 6x, du, which is just the times 1 here. We're evaluating that antiderivative with respect to x. Okay, so now it's simpler because we can evaluate this without having to do integration by parts. So let's just clean it up real quick. This is negative x over 6 cosine 6x. And then we can factor out the constant here. So this is now a positive 1/6 times the indefinite integral of cosine 6x with respect to x. And now this antiderivative we can evaluate directly. It's just like what we did over here with dv and v. So that's, again, something that's been covered previously in a calculus course, so you'll want to go back and check on that if you're not sure how to evaluate that antiderivative. But a basic walkthrough of what that antiderivative is we're going to need a sine. This is sine of 6x. But because of the chain rule, if I was to take a derivative right now, you get an extra 6 out multiplying to the outside. So we have to multiply this antiderivative by 1/6. Okay? Because now you can check my work. If you take a derivative of this, it should turn back into this. 1/6 cosine 6x. And then cleaning up a little bit more, that's negative x over 6 cosine 6x. And then this is plus 1 over 36 sine 6x plus some constant c.